So today I want to talk about approximating pi because if you're anything like me, when I was taught pi, I was told that it's the ratio of a circle's circumference to its diameter. But that number, 3.14159265359, that goes on into infinity, um, that number was kind of like elusive to me. How do you get that? How do you even begin to get that? Well, here I'm going to demonstrate how we can visually approximate the value of pi so we can get maybe a little bit more of an intuitive feel for what pi actually is or how we get that number. And we're going to do it by looking at these circles that are circumscribed with polygons. So as you can see, the more sides that a circumscribed polygon has, the closer the ratio of the perimeter of the polygon to the diameter of the circle is to pi. So for example, here we have a square, and if I look at the perimeter of the square versus the perimeter of the circle, or in other words, the circumference, we see that there's a lot to be desired there. There's a little bit of a difference there. But if I double the number of sides of a polygon and I have an octagon and circumscribed into the circle, I can see that if I take the perimeter of this polygon, it's getting closer in value to the circumference of the circle. And if I double the number of sides of the polygon again to 16, here I see we're starting to get pretty darn close to the value of the circumference of the circle if we're adding up the lengths of the polygon, of the size of the polygon. And so if we continue on and add more and more sides to the polygon, it's going to get closer and closer and closer and closer to the value of the circumference of the circle. So if I have a circle with a diameter of 1, then the ratio of the circumference to the diameter is just going to be the value of the circumference of that circle. So to make our life easier, I'm going to be working with a circle of diameter of 1, so I don't have to make an extra division. So let's take a look and see how we can approximate this. Well, to do this, I want to look at a pattern, see if any pattern emerges as I try to find uh, the perimeter of the polygons. So if I have an a plus b over c, and then on a next iteration I have the same a plus b over c, except that for the b, I replaced the original value as that b. And then on a next step, on a next iteration, I do the same thing. I take an a plus b over c, but for the b, I put in the previous iteration's value. We're starting to see a pattern emerge. And that's what we're going to be looking for in this case, is a kind of pattern that emerges as we continue to increase the number of sides of our polygon. So let's start with the square inside the circle. To save time, I'm just going to make, or save space, I mean, I'm going to make a half circle and inscribe it there. So this length is going to be 1/2 because our diameter is 1. And being that it's a circle, then this length is also going to be 1/2. And to find this length c, then I would use the Pythagorean theorem. So 1/2 squared plus 1/2 squared is equal to c squared. So that's 1/4 plus 1/4 is equal to c squared, which is equal to the square root of 2 over 2. Right? 1/4 plus 1/4 is 2 over 4, and then you take the square root of 2 over 4 is the square root of 2 over 2. Okay, so that means the perimeter is equal to 4 times c, which is equal to 2 times the square root of 2. So now if I double the number of sides, by cutting that in half, then since any line that comes from the center of the circle up to the edge is going to be 1/2 in length, then we're going to have a triangle here where these two lengths are known as 1/2, and this here is going to be a right angle, because since this is also 1/2 in length, and we're joining the two sides here and cutting it in the middle, that's going to make this one a 90-degree angle. So this length is c over 2, this length here, and this length over here, this length here is also going to be c over 2. But I'm going to pretend that I don't know that. I mean, it's c over 2 because, if we're cutting a 90-degree angle here in half, that means that's 45 degrees. That means this is also 45 degrees. So that would also be c over 2. But I'm going to pretend I don't know that because it's going to be helpful for me to see a pattern later. So let's say I don't know what this length is, the red line here. If I want to find it, then I can use the Pythagorean theorem again. Let me call this x. So it'd be x squared plus c over 2 squared is equal to 1/2 squared. So that means x squared is equal to 1/2 squared minus c over 2 squared, which means x is equal to the square root of 1 minus c squared over 4, which, taking the square root of 4, would give us 2. So that's the value of x. So in order to find this side here, then that would be 1/2 minus the square root of 1 minus c squared over 2. And then we can use the Pythagorean theorem to get the value of this length here, t, of that right triangle. So that would be that squared plus c over 2 squared is equal to t squared. So if we're just doing the part in purple, that becomes 1/4 minus 2 times the square root of 1 minus c squared over 4 plus 1 minus c squared over 4. So now we add the c squared over 4 from the other term. It's equal to t squared. And these cancel. And we're left with 2 minus 2 times the square root of 1 minus c squared over 4 is equal to t squared. And t then becomes square root of 2 minus 2 times the square root of 1 minus c squared over 2. So that's t. And the perimeter is equal to 8 times, because there's 8 sides in the polygon, 8 times t, which is equal to 4 times the square root of 2 minus 2 times the square root of 1 minus c squared. And so let's see one more level higher. Let's look at 16 sides of a polygon. For 16 sides, because I'm going to run out of space, I'm going to just take a little chunk. I'm going to take a chunk of the triangle. So I'm going to look at this part of my triangle here, down below. So I have, and I'm going to exaggerate the curve here on the triangle, because otherwise it's going to be kind of hard to see the lines that I'm trying to draw. So I know this is 1/2. I know this length is t. The entire length here is t. I know this length is 1/2. So if I want to make a polygon with 16 sides, I have to bisect this one. And since we're bisecting this triangle with the same lengths on this side and on this side, that means that this is going to be a right angle, just like before. And this length here for this side is going to be t over 2, t divided by 2. And so similarly, to find this length, just like in the previous case, we can take, let me call that x, we can take x squared plus t over 2 squared equal to 1/2 squared. Well, notice how it looks identical to this formula here, except this one only has a c, whereas the other one has a t. But it's the exact same formula. So our end result is going to have the exact same form as our polygon with 8 sides in it. So let's just go through it just to, help us feel comfortable with it. So here we have x equal to the square root of 1 minus t squared over 2. And so if we square, or if we take the 1/2, which is the length of that whole side, and which includes this side here, then we have 1/2 minus the square root of 1 minus t squared over 2. And we can square that and use the Pythagorean theorem and square the t over 2, which is equal to v squared. Let me call this v. I'll use a different color here, v. So, just like before, this part in here becomes 1/4 minus 2 times the square root of 1 minus t squared over 4 plus 1/4 minus t squared over 4, and then plus t squared over 4, which is equal to b squared. These cancel out, and we get 2 minus 2 times the square root of 1 minus t squared over 4 equal to v squared. So it becomes that. So here we see the formulas for the length of the side of the polygon are very similar. And the more you divide the polygon up, since you're going to be using the same method, the same logic for each time that you increase the number of sides of the polygon, it's always going to have that same structure. The only thing is the value of your polygon length from your previous polygon is going to be the value that's going to be squared in your next polygon. And the perimeter here then is, because we got 16 sides, so 16 times v, which is equal to 8 times the square root of 2 minus 2 times the square root 1 minus t squared. So notice the similarities there. So now let's look at the structure of this formula with the value of c fed into it. So now for our value of c, we know that c is equal to the square root of 2 over 2. And so if we're going to plug that into our value of t, then we've got the square root of 2 minus 2 times the square root of 1 minus c squared. And that's over 2. So c squared is equal to 2 over 4. And 1 is 4 over 4. So 4 over 4 minus 2 over 4 is 2 over 4. So we got the square root of 2 over 4 times 2 minus 2, square root of all of that. And that reduces to square root of 2 minus the square root of 2 over 2. So that's the value of t. If we then take v, which was the exact same formula as the one for t, except that instead of a c squared, we have a t squared over 2, and we feed that into it, then we get that, and that ends up being equal to, if we take just the part that's inside the square here, we'll get 2 minus square root of 2 over 4. And again, the 1 can be written as 4 over 4. So 4 over 4 minus that. And then we take the square root to, well, we got to distribute this negative. So that'll end up being this negative here. We got to distribute that negative through. So that'll end up being 4 minus 2, so it's 2. And then the negative here times this negative here would be a positive. So it'd be positive square root of 2 over 4. And we know that the square root of 4 is 2, so that's going to end up being 2 minus the square root of 2 plus the square root of 2. It's the value for v. So, the perimeter for that would be 16 times v. So it would be 8 times the square root of 2 minus square root of 2 plus the square root of 2. And if we ended up doing like 32 sided polygons, so then one side would be equal to, if we did the same kind of calculation, we'd see a very similar result. So it ended up being, the one side would be the square root of 2 minus the square root of 2 plus the square root of 2 plus the square root of 2. And so on. So the perimeter would be equal to 16 times the square root of 2 minus square root of 2 plus square root of 2 plus the square root of 2. And let's see what that, if we do that in the calculator, what would that more or less come out to? And it turns out that comes out to 3.136548,491. So we can see we're getting closer now to the value of pi. And if we continued this progression of ever increasing number of sides, then for an inscribed polygon with 2 to the n sides, you'd get, for the perimeter, it would be 2 to the n minus 1 times the square root of 2 minus the square root of 2 plus the square root of 2 plus, and you'd continue with more and more square roots, and there would be n minus 1 roots. And so just to give you an idea, if we had inscribed polygon with 128 sides, then the perimeter is equal to 3.141277251, and an inscribed polygon with 512 sides has a perimeter equal to 3.14157294. So you see we get closer and closer to that irrational number pi. So hopefully this gives you a little bit more of like an intuitive feel of how we can approximate that number pi. Thanks for watching, and please subscribe.